Hey everyone, welcome to our channel. I'm Dhanush, and today we have something super exciting lined up for you. We are diving into the world of algorithms with a hands-on project, creating a website for quick visualization. But before we jump into coding, let's take a sneak peek at what our website looks like. So let's run it. So let's check it. So yeah, it gets started. Pretty cool, right? Our amazing team of four has worked hard to bring this to life. Now let's talk a bit about Quicksort. Imagine you have a messy pile of books and you want to organize them. Quicksort is like having a smart friend who helps you to do this efficiently. It uses a technique called divide and conquer. Here's how it works. You choose a pivot book. In this example, it's a book, and then you arrange all the other books around it. Those that are lighter on one side and those that are heavier on the other. This way, the pivot finds its perfect spot and the process continues until everything is sorted. Got it? Great. Now, to make this even more interactive, let's see how we can.
Hello everyone, this is Kavya. I'm going to explain Quicksort with an example. Quicksort is a divide and conquer sorting algorithm which sorted the array into recursively. It includes three key points. First, it chooses the pivot value and it partitions the array around the pivot value and recursively sort the subarrays. So let us take some example. And here we and our array is -6, 28, -2 and -4. So first we chooses a pivot value. Here we chooses 4 as our pivot value. And the elements which are less than the pivot value become left subarray and the elements which are greater than the pivot value become right subarray. So again we apply the quicksort on left subarray and right subarray. Here again we chooses a pivot value. Here -2 is our pivot. And partitions are into two arrays, left subarray and right subarray. Similarly for the right subarray. When we complete sorted the all elements, then we combine these sorted elements. Here we combine -6 and -2, left subarray, and right subarray 8 and 20. Then again we have two subarrays, -6, -2, and 8, 20. So again we combine these subarrays and we got our sorted array -6, -2, 4, 8, 20. Like this, our quicksort is it should sort the elements like divide and conquer method. Thank you. Now my friend will continue how to display these quicksort in a web page. Thank you.
This HTML code is a basic structure for a web page that visualizes the quicksort algorithm. Doctype HTML defines the document as an HTML5 document. Head is the beginning of the head section, which includes metadata. Meta card sets the character for supporting various symbols and text. Title sets the web page title that appears on the browser tab. Body. The main content of the web page starts here. Dive creates a navigation section with a class nav. Nav begins the navigation bar. H1. H1 is the main heading for the page. P is the paragraph explaining quicksort. Input ID creates a text input field where users can enter numbers to be sorted. Dive class is equal to container, a container to display the array and sorting animations. Uh, the closing tags body and HTML for elements marking the end of the HTML document. This is CSS code. Body sets the background color of the entire page. Text color is set to black. Nav. Nav defines the navigation bars background color. Nav uses the flexbox layout to space out items evenly within the navigation bar. Home button. Home button defines the button background color, uh, text color. .bod sets the layout of the main content using flexbox. The content inside will be arranged in columns. H1 adds 20 px space below the heading. Center P centers the text inside the paragraph. Button have a green background with white text and round coordinates. Train uses the flexbox to arrange elements in row without wrapping. Char items are displayed as inline blocks with spacing. Abbreviations are underlined with dotted line. This CSS code creates a structured, responsive web page with buttons, text, inputs, and dynamic elements.
Hello. This is a JavaScript code that implements the quicksort algorithm and visualizes the sorting process. It appears to be a part of web application that takes an input array from the user and sorts it using quicksort. First, it starts by defining some global variables. Here is an empty array to store input values, and here a counter to keep track of the current step in the sorting process that is initialized with 1, and the display steps it is initialized to an empty object. Then here to get the input field and array container. Next pairs and the input array. This function pairs the input field value and returns an array to the numbers, and it also uses the split function method to split the input string into an array of substrings using commas as a separator, and then it also uses the map function method to convert each substring into a number. And next, display array has a train format. Here, function display array. This function displays the array as a train of cards with each card representing a value in the array. It creates a new element and each step and appends it to the array container element. It then creates a new element for each value in the array and appends it to the train element. It also uses some CSS classes to style the visualization. Next, here is the quicksort logic. This quicksort logic algorithm implementation, it takes three parameters that are the array to sort the low index and the high index. It uses recursion to sort the subarrays on either side of the pivot, and it displays the array after each partition step using the display array function. And the next, partition logic for quicksort. This is the partition logic for quicksort. It takes the three parameters that are the array to partition, the low index and the high index. It selects a pivot element and partitions the array around it. It uses a loop to swap elements that are less than the pivot to the left of the pivot and elements that are greater than the pivot to the right. It displays the array after the final swap using the display array function. Next, quicksort visualization. This function starts the quicksort visualization process. It pairs the input array using the pairs input array function. It displays the initial array using the display array function. It calls the quicksort function to sort the array. Next, this code adds an event listener to a button which calls a quicksort visualization function when it is clicked.